In this video, I want to address sort of a really big issue in our system that we're setting up, trying to render things quickly. I've been doing a bunch of tweaks, but those tweaks were not fundamentally changing performance. And the reason is that there's a really big bottleneck, which is that we've got, imagine this is 3D, top-down view. We're looking here, we've got a whole bunch of objects uniformly or somewhat distributed around us, but only some of them are actually visible. And yet we're still throwing all this work at the GPU. It's pretty good, but it's not a machine. So, well, it literally is a machine, but you know what I'm saying. So the basic idea is I want to implement some sort of test before I render to check whether the object is at least somewhat within my view. Remember that we have the model view projection matrix transformation set. And the result is after we apply all of those matrix transformations, we get into basically something called clip space. This might be a bad diagram. Okay, so we've got our sort of field of view represented here, and we hit it with a model view projection transformation, and it sort of maps to a cube or something where everything is in normalized device coordinates. So, you know, x equals -1 is off on the left of the screen, +1 on the right. We've all been here before. And we also have, I want to say, a -1, I think. Anyway, doesn't matter. It maps the world. The visible region of the world gets mapped to this cube, which is a size of 1. So the basic idea is we'll have some object. Here it is. It's spun around a little bit. And we will construct some sort of AABB, axis-aligned bounding box, around that object. We then project it into screen space, and then we want to check whether that box is, again, somewhat on the screen. And the way I'm doing this is with an exclusion test. So if I've got the left coordinate, if that left coordinate is further to the right than the rightmost section of the screen, then that's a fail. And then I'll go ahead and I'll do that for all of these edges. So again, for instance, we'll have our right-hand x coordinate is over here. If our rightmost coordinate is to the left of the screen, then that's a fail. And yeah, we'll do it for everything. Now, this is fine if nothing's rotating. If things are rotating, then it gets a little bit different and a little bit more complicated, but here we have it. So imagine this is our screen, and here's an object, and the object has gone and rotated. One thing we can do is we can take the corners of the box and transform them, and then do the test on that box. But it's a little bit of a problem with using that exact box, because there are cases where an object is visible, but if we were to look at all the corners of that box, they would all be outside of the visible range. Somewhat. So sort of my hack for that is I take those corners and I use those corners to construct a new box and then check whether that box is visible or not. So again, the process is we have a box around each object. We hit it with the model view projection transform. That'll put it into screen space. Then we transform each of the corners of the box individually, use those corners to construct a new bounding box, and then test that bounding box against the screen. So that's the basic idea, and I'm going to do a little roadmap of what we'll go through. So the first thing we need to do is we need to define a struct for our AABB. Then we'll say, okay, every mesh that we load has to have an AABB. Okay, then I'm going to go to my camera system and I'll say camera. I'll say camera remembers its, I'll say view projection matrix. Then camera contests an AABB. And I'll say contest an AABB and model. So if I give you an axis aligned bounding box and a model transform and I say, hey, can you see this thing? The camera can say, yes, I can see it. No, I can't see it. Then the next thing is there's another step here. As well as this, the model factory will build an AABB for every mesh. Oops, is that visible? There we have it. Okay, cool. So then my render system is going to need to know about the camera system. So I'll say render knows camera. I know some of these steps are a little silly, but I like to have a bunch of things I can just tick off. Get the feeling of progress, you know what I mean? Okay, then the render system will be able to query the camera and exclude meshes. So we'll say can exclude meshes. Okay, cool. So that's the roadmap. Let's get into it. Okay, so action time. We are good to go in our code. Maybe, you know what, before I do anything, I'll just run to see like what this looks like. So we've got a bunch of objects and I'm going to make one change, and that is this, I think the board and the trees are a little big. So I'm going to shrink them down a little bit. I don't know, some of these objects are just a little too big. So tree, oh my goodness, it's already shrunk down so much. Maybe just leave it. Okay, cool. So we've got a bunch of objects. This is what that looks like. It's a little messy, I know. So we've got a bunch of objects rendering at 42 frames per second. Okay. So just bear that in mind. Right, so now I'm in my config header and I'm just going to go right down here and I'm going to define my AABB. Generally, the way I work with these is I have my min corner and I'm going to, I'm going to go ahead, give them some default values. The reason I'm choosing this number here is I just want an impossibly large number so that every time I try to shrink down that corner, it'll always be shrinkable. Does that make sense? I'm giving it a meaningful default value. Same for the maximum. So, alrighty. What do I have? Define AABB, done. Okay, next one. Every mesh has an AABB. Too easy. Just like that. Okay, so that one is done as well. Cool. Right, next one. Model Factory builds an AABB. So I'll go over to my Model Factory. And right down here, I've got this mesh. And I'm going to need to work with these points as they come in. So this first run through, I'm basically reading how many of these things I should allocate. But here I'm actually working with them. So I'm just going to take this line here where I've read this vec3, going to make that a new variable called pos. There we have it, because I'm also going to use that to grow or shrink my box. So go mesh, mesh box min, and that will shrink down. So we'll take the element-wise minimum of that box and the new position that we just read. And I'll do the same thing for the maximum, but obviously, you know what I'm saying. Okay, so that is done, I hope. The next thing is the camera is going to need to remember its view projection matrix. So I'll just go over to the systems and then the camera system. And in this camera system, I'm going to define, basically hold on to that because we're going to use it. And then I'm going to need some sort of function that returns a Boolean, and it's going to be named visible. It's going to take in a box and a model transform. There we go, and why not? Okay, so I'll just go over to the source file and define this. Sort of go down. Maybe I should modify this to, I'm talking to myself. Okay, so we don't need to define that as a local variable. It's fine. Okay. Indecisive, I changed my mind, we'll put it here. Okay, so like I said, there's a few steps. One step is I'm going to take that box and I'm going to use that box to construct a new box. Or basically I'm going to construct all the corners. So I'm going to have an array of 3D vectors. And I'm going to get that by building a bunch of new vectors. So first of all, I'll take all of the corners of the minimum. There we go. So this is the corner which just has all the minimum components, and I'm just going to duplicate this a bunch of times. Is that 8 times? There we go. Cool. Okay. And now I'm just going to selectively swap these around. So I'm just, 2 to the power of 3. I'm just taking, oh my goodness, can you just get out of my way for a second? I'm just trying to get all the possible combos. Oh my goodness. Okay, cool. There we have it. So this is all the corners, and then I'm going to need a new AABB, which is going to represent the box containing the transformed corners. So I'm going to say, hey, we're going to have a new AABB, which I'm going to call screen box. That sounds fine. What? Oh, whoops. Okay, cool. So now I'm going to look through every corner. So I'll say go from 0 to 8. And then for each of these, I'm going to need to transform everything. So I'm going to have that transformed point, which I'll call P. And I'll get this by the view projection matrix model and the current corner. Cool. So, as I'm sure you're very familiar, we read these backwards basically. So we start with the corner, put it out into world space, and then put it into screen space. But we're not quite in screen space, because in OpenGL, when we do this sort of transformation, under the hood there's a perspective division which occurs, and we're just going to do this by hand. So after we do this transformation, the P will have the XY something. It's actually approximating Z squared, but then we're going to have the W component of P holding the distance that the point is. So I'm going to basically take component-wise. So I'm going to say, hey, the X component, just divide it by the W component. And I'm going to do this for the Y and the Z, and this will get me into normalized device coordinates. Okay. So then I've got my point, I've transformed it, I've really got it in NDC now. I'm going to grow and shrink the box. So I'll say, alrighty, screen box min and I'm just going to need to convert that to a vec3. Okay, and we'll do the same thing, growing the box as well. Okay, by the time this loop finishes, we should now have a bounding box in normalized device coordinates, which is holding the transformed box. And so we just need to do our test based on that. So I'm going to write out a fully naive way, and then I'll talk about it a little bit. So basically we could go, hey, if we get the screen box, and it's, yeah, the minimum X coordinate is greater than 1.0, then yeah, we're off. Otherwise return true, and then I'm going to need to do the same thing for each of the other components. What I could do now is I could have a separate if statement to look at the maximum, but I'm going to chain these together, even though it's it's not very aesthetic, but I'm still going to do it. For the reason that conditional code can be slow. So it's faster to evaluate a bunch of binary operations, a bunch of Boolean conditions, get them down into one, and then worry about the overhead of the if statement. So we've got that. But if I look at this statement, I've got it all down into one case. That's really good. But this if is, it's like if this thing comes out to true, then return false, otherwise return true. And that is equivalent to simply taking this and evaluating it directly. So if I take this expression, negate it, and then return it. Let's make this a little more readable. Because these are all, oh my goodness. These are all the cases that will cause it to fail. So if none of them happen, then we're good. Cool. And by the way, if you're curious, I did try this with and without. It made no difference, but this gives me a good feeling, so I'm going to do this. So there we've got our visibility test. The next thing we need is for the render system to know about the camera. So I'm going to go to the render system, and up here on my includes, I'm going to go ahead and include the camera. And I'll just put in here, okay, when I construct the render system, I'm going to pass it a pointer to the camera system. Oops, which will be, where are we? That'll be saved here. And then I'll just go through and do the dance. So I'll go to the initializer for the render system and say, alrighty. We'll save that, and we'll just go to the app, and at the point where we construct that render system, I'll just, where are we? Create systems, make systems, where are we? Here we are, okay. Alright, so I'm happy with that. I'll just go to my render system, and finally we're going to need to exclude non-visible objects. So at this point here, I'm going to take this build model transform, and I'll make that its own variable, call it model. Like that. And now I'm going to do my test. So I'll say, alrighty. If the camera system cannot see the box around the mesh under this given model transform, then we'll just continue. And we'll look at the next mesh. There we have it. So remember, we were running at 43 frames per second. Now, knowing me, I'm probably going to make an error here, but let's see what happens. Okay, so we've taken that 43 frames per second, and that is now up to 173 frames per second. Cool. This is making me happier. Looking around, I cannot see any objects like suddenly popping in and out of view, so I'm satisfied that the culling is working properly. It's yeah, no, that's good. I'm happy with that. Culling is working properly. It may not be the most a mathematically efficient or rigorous method, but at this point, I'm just looking for stability. Right, so this gives me some hope that in the subsequent videos, some of the techniques I use will have a greater effect on the frame rate, because I reckon that we can probably push it up a lot. Anyway, so that's it for today. Hope to see you again soon. Bye. Hello. I just want to give a quick little shout out and thank you to all of my channel supporters. I'm community fund. That's a tough word. I'm community funded. It's how I keep the lights running. Not really, but you know, it's how I... So I really appreciate any and all support. If you can't support financially or don't want to, look, that's totally fine. It's not expected. It's sort of a premium subscription thing. In that case, the best thing you can do to support the channel is to comment. Let me know what you're liking, what you're not liking. I know I do a bunch of things, but I am trying to make the best educational content that I can. So, big thank you to Antonin Carret, Dankil Foles, Declan, Enderlon Studios, Isaiah Meyer, Jason Coleman, Mathieu Durick, Moim, Shreyar, and Maxim Shukim. Thank you so much, my dudes. It really does mean a lot. Yeah, cheers. Gonna get hit. Have a good one, and I'll see you again soon. Bye.